Hello and welcome back to Educational Mechanics. I'm Matt, and in this video we're going to look a bit deeper into the air braking system, in particular at the air brake relay. So hold on to your seats. A quick recap on what we already know, but if you want a bit of a refresher, click here to watch our Introduction to Air Brakes video. So, we've got an engine-driven air compressor that supplies a reservoir which holds compressed air ready for use. The reservoir supplies the driver's controls. Then the driver controls where the air goes. Releasing the park brake by the hand control valve supplies air to the secondary chambers, compressing the power spring, which takes the brakes off. And this air remains in the secondary chamber all the while the park brake is in the off position. We're now driving along. The driver uses his foot brake pedal, known as a foot control valve, to control the air to the service chambers, applying the brakes as and when they're needed. And once again, when we're done, we reapply the park brake. The air is exhausted from the secondary chambers, allowing the power spring to reassert its force and apply the brakes. Now in theory, this operation would work really well for smaller vehicles, but when we have a larger commercial vehicle, the effects of brake lag would make the system unusable. Let's rearrange the system components to where they would be on the vehicle and have a look at this brake lag thing. Right then. As we had before, the air compressor supplies a reservoir which holds compressed air ready for use, and the reservoir supplies the driver's controls. But it takes far longer for the air to reach the secondary chamber on the spring brake actuator, and in turn compress the power spring and release the brakes. But that's not so bad, is it? Just takes a bit longer for the park brake to be released. Well, let's have a look at the service brake then. As the driver applies the foot brake, it takes a relatively long time for the air to travel to the rear service brake and build up in sufficient quantity to apply the brakes. Now if you want to stop in a hurry, this is not a good thing and could end up with serious consequences. This brake lag would also occur when the foot brake is released. So clearly we need to find a solution to brake lag. How do we do this? By fitting a relay, which is a device designed to speed up the application and the release of the brakes. Let's rearrange this system with a relay for the rear service brakes and have a look at how it affects the system. Right then. What we've done here is put a relay at the back, close to the rear service brakes, and also put a reservoir there, so it's got a close by supply of compressed air. Now, we only need a signal pressure to activate the relay, so we can use small pipes, allowing the signal to get from the foot control valve to the relay much quicker than with our previous large piping. When the driver applies the foot brake, the signal pressure is sent to the relay, which in turn uses the compressed air in its own reservoir to make that same application to the rear service brakes with the larger pipes, minimising the brake lag. And on releasing the foot brake, only the signal is exhausted from the foot control valve, while the main air that we're using to apply the rear service brakes gets exhausted through the relay. And that's how we solve the problem of massive brake lag with a relay. Now we know we can use a relay to speed up the application and release of the service brakes. We can put relays in other systems, like the secondary or park circuit. Right, when the driver releases the park brake, the signal pressure is sent to the relay, which in turn uses the compressed air in its own park reservoir to release the brakes. And then again, when the driver applies the park brake, the signal is quickly exhausted and the park brake applied. This is all done with minimal lag. Okay, so let's have a closer look inside the service brake relay and see how it works. Here we have a cross-section of a relay. Now relays come in different shapes and sizes by different manufacturers, but they all pretty much work the same way. We have three main ports on a relay. The first is a supply port, which is connected directly to the reservoir, so the relay's got a constant supply of compressed air. The second is the delivery, which goes to the rear service brake chambers. And the third is the signal port, which receives the signal from the foot brake valve. And we also have an exhaust on the relay. In the rest position with the brakes off, the exhaust port is open and the delivery line is open to atmosphere, so there can be no pressure build-up in the brake chambers. The relay valve is in the off position. When the driver makes a foot brake application, air is sent down the signal line and starts to act on the top of the piston. With pressure above the piston and nothing below, the piston moves down to seal off the exhaust port. With pressure still above and nothing below, the piston is forced down further until it acts on the inlet valve, which opens and allows compressed air from the reservoir to go to the brake chambers, applying the brakes. The valve is now in the on position. Now this is all happening very quickly, and what happens next is the air pressure has built up in the service brake chamber and the delivery line, and this pressure backs up and is felt on the underside of the piston. With equal pressure above and below the piston, the return spring on the inlet valve asserts itself and closes the inlet valve. With both the inlet and the exhaust valves closed, the relay is now in the hold position, as the pressure is held constant in the service brake chamber. So the driver has his foot lightly on the brake pedal, and we'll say the signal pressure is about 30 pounds a square inch, which means that the delivery pressure is also about 30 pounds per square inch. The driver's foot now only has two ways to go, either on more or off more. If he applies a bit more force to the brake pedal, the signal pressure will increase. The pressure above the piston will be higher than under the piston, so the piston will move down and once again open the inlet valve, which opens and allows more air to be delivered to the brake chamber. The pressure equalises and the return spring closes the inlet valve, and we once again find ourselves in the hold position. Right, this time the driver is going to remove some force from the pedal, but not all of it. The signal pressure above the piston reduces. With a higher pressure below the piston than above it, the piston is forced up, opening the exhaust valve, allowing air from the brake chambers to be exhausted through the relay. With the inlet valve closed and the exhaust open, the valve is in the off position. So when the delivery line is exhausted enough and the pressure under the piston has decreased, the pressure above acts on top of the piston, forcing it down, sealing off the exhaust, and places the relay once again in the hold position. Right then, the driver is now going to completely remove their foot from the brake pedal. The signal is exhausted through the foot brake valve, and the air pressure under the piston from the brake chamber lifts the piston, opening the exhaust valve, allowing the air to be exhausted through the relay. The valve is once again in the off position. So looking at that, the relay valve is always either in the off, the on, or the hold position. And all this happens very quickly. And there we have it, the air brake relay, there to minimise the brake lag and speed up the application and release of the brakes. We'll have a look at more air brake components in other videos. Thanks for watching. Bye.